Hi, welcome back to Docker presentation. This is Satyadev. In the last presentation, we have seen operating system virtualization, or simply called virtualization, using virtual machines. So we also seen in order to create virtual machines, we need hypervisors. Now in this presentation, we are going to talk about operating system virtualization, which is nothing but the containerization. So which is also known as the containerization. So what is operating system virtualization? Let's get into the details. So basically, operating system virtualization, also known as containerization, means a single operating system kernel allows multiple isolated user-specific instances to run on a single physical machines. So which is known as the container host. So these instances, known as containers, operate as independent environments but have shared host file system layers, run their processes on host OS, and use host network configurations. In order to provide OS virtualization, a special software called Container Engine is needed to be provided on the host machine. It is almost similar to hardware virtualization, but there is a big difference. So we'll see what it is. So basically, you have the host operating system, host machine. On top of that, you have host operating system. Now, earlier we have seen hypervisor is there. Here we have a container engine. Instead of hypervisor, we have a container engine. Each container engine will create containers, which is like virtual machines in the hardware virtualization. So in the OS virtualization, we call containers. In the hardware virtualizations, we call them as virtual machines. So let's take an analogy of containers. Real world analogy for OS virtualization, which is nothing but operating system virtualization, which is achieved through containerization, is like a commercial complex having, you take a commercial building, marketplace. So again, it has a base in common foundation and structure, and it has got a lot of stalls. But if you observe, those stalls are like, they are there, but they don't have a lot of energy sources, like they don't have like food court. For example, there is no kitchen, there is no, each has got its own specific stuff. That's pretty much it. It doesn't have a mimicking type of things. Like for example, in, let's take a mall, right? In that mall, you have one clothes store, another perfume store, another electronic store. They're all different things. They're all different stores. But whereas in apartments and flat, you have a family living in one flat, another family. So it's like, and each room, each apartment has got similar kind of rooms. There is a living room, dining room, bedrooms, halls. All these things are going to be there. Whereas in a mall, in a mall or a shopping complex, the stuff, the stalls have business and merchandise. That's specific to their business. So but they're all under the single property, right? So that's what pretty much is. Pretty much it is. So basically, operating system virtualization, it has a base OS, but there are no guest OSs. It just takes the base OS. That's pretty much the difference between hardware virtualization, operating system virtualization. Let's see this diagram. In this diagram, again we have the base hardware, host operating system kernel, right? So then on top of that, we have something called container engine. In fact, Docker is an engine, container engine, which is an example for container engine. Like similar to VMware is an example of hypervisor. Similarly, Docker is an example of container engine. Now, if you see, there is a container engine. Now you see, this is a container. In this container, you don't see any operating system, right? It has only libraries and application. So this is how the containers works. Now, again, this is another container, this is another container. Now, all are independent. All are independent, even though they share the same OS, and there is no OS inside, these machines. They just have only the corresponding application code and, libraries required. Now, I said shared kernel. That means, fundamentally, all these containers are hosted on the same operating system. So they should be compiled for that particular operating system, right? Whereas in the case of hardware virtualization, you can have a Windows machine which can host a Linux machine, whereas in containerization you can have a Windows machine, but it cannot host a Linux machine. It can have only Windows based containers. Similarly, a Linux machine can have only Linux based container. That's how this system works, right? So this is how it is. So thank you very much for listening to this, watching and listening to my talk. We'll meet in the next video. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.